Look down. Right now, beneath your feet, an empire is at work. They do not raise monuments of stone. They do not write laws or wage wars with flags. Yet they have built one of the most successful civilizations the earth has ever known. They are the ants. There are more than 12,000 described species of ants, and scientists estimate that thousands more still wait in the shadows to be discovered. If you could place every ant on the planet on one side of a scale and every human on the other, the ants would hold their own, and in many tropical forests they would tip the balance. In some ecosystems, they make up more than a quarter of the entire animal biomass. An ant is never just an ant. It is a single living cell in a vast superorganism called the colony. That colony can contain a few dozen individuals, or more than 20 million. At the center of nearly every colony sits the queen. She is not a monarch in the human sense. She does not issue commands. She is a living factory. In her lifetime, a single queen may lay tens of millions of eggs. The workers that hatch from those eggs will never reproduce. Almost all of them are sterile females. Their entire existence is devoted to the survival of their mother and their sisters. This radical sacrifice is one of the secrets of the ants' extraordinary success. Evolution has written a simple rule into their bodies. The individual is expendable. The colony is everything. Inside the colony, there is a quiet hierarchy of roles. The smallest workers often care for the eggs and larvae, cleaning them, feeding them, and moving them deeper into the nest when danger approaches. Larger workers leave the nest to forage. In many species, a third caste appears, the soldiers, with oversized heads and powerful mandibles designed for defense or for cutting through tough material. Males exist only briefly. They are produced in large numbers during a short season, fly out to mate in vast aerial nuptial flights, and then die. Their only purpose is to pass on genes. After the mating flights, the newly fertilized queens shed their wings, dig a small chamber in the soil, and begin the lonely work of founding a new colony. Often alone, living off the fat reserves in their own bodies until the first workers emerge. How does a colony of thousands or millions coordinate without a single brain in charge? Through chemistry. Ants speak in scent. A forager that finds a rich food source lays down a pheromone trail as she returns. Other workers follow it, reinforcing the chemical signal with every successful trip. Within minutes, a river of ants can form, flowing with remarkable precision toward a single leaf, seed, or dead insect. When danger appears, alarm pheromones explode into the air. The peaceful trail can transform in seconds into a coordinated army. Some species even release propaganda chemicals during battle, substances that confuse the enemy's own communication system and turn their soldiers against one another. Consider the leafcutters of the Americas. They do not eat the leaves they harvest. Instead, they carry them deep underground into vast fungal gardens. There they cultivate a single species of fungus that grows nowhere else on Earth. The ants carefully weed the gardens, apply antibiotics produced in specialized glands on their bodies, and feed the fungus with a steady supply of fresh plant material. In return, the fungus produces nutritious structures that the ants harvest as food. These ants are the planet's oldest known farmers. Their agricultural system has been running, refined generation after generation for more than 50 million years, long before any human ever planted a seed. Other species have evolved equally astonishing lifestyles. In the deserts of the American Southwest and Australia, honeypot ants turn some of their own sisters into living storage vessels. These specialized workers hang from the ceiling of the nest, their abdomens swollen into translucent golden spheres filled with sweet liquid. When food is scarce, the colony drinks from them. Army ants of the tropics do not build permanent nests. Instead, the entire colony, queen, workers, and brood, moves as a single predatory wave across the forest floor. They form temporary bivouacs made of their own linked bodies. When they encounter a gap too wide to cross, some workers lock legs and mandibles to create living bridges so the rest of the colony can pass. Certain species have become slave makers. They raid the nests of other ants, steal the pupae, and raise the stolen young as workers in their own colony. The enslaved ants perform all the labor, while the slave makers specialize only in raiding. The architecture of an ant nest can be breathtaking. Some species construct towering mounds of soil and plant material that regulate temperature and humidity with remarkable precision. Others excavate elaborate underground cities with specialized chambers for brood, for food storage, for the queen, and for waste. The air inside these nests is carefully managed. Tunnels act as ventilation systems, and the ants actively move brood from chamber to chamber as conditions change. A single mature leafcutter colony may contain hundreds of interconnected chambers and stretch several meters underground. The soil they excavate can form mounds large enough to be mistaken for the work of much larger animals. Pound for pound, ants are among the strongest animals on Earth. A worker can lift objects many times her own body weight and carry them for remarkable distances. When floods come, fire ants link their bodies into living rafts that can float for weeks, keeping the queen and the precious brood safe in the center. When the nest is attacked, soldiers rush forward without hesitation, ready to sacrifice themselves so the colony may live. This willingness to die for the group is not courage in the human sense. It is the logical outcome of a genetic system in which workers share more genes with their sisters than they would with their own offspring. The colony's survival is the workers' evolutionary success. Remove the ants from many ecosystems and the consequences would be profound. They aerate soil as they dig. They recycle nutrients by breaking down dead insects and plant material. They disperse seeds. They control populations of other insects. In tropical forests, they are so abundant and so active that they shape the very structure of the plant community. Some plants have evolved to offer ants nectar and shelter in exchange for protection from herbivores. The relationship can become so tight that the plant cannot survive without its ant partners. Ants first appeared more than 100 million years ago, during the age of dinosaurs. The earliest fossils already show the hallmarks of social living. Over deep time, they radiated into almost every terrestrial habitat on Earth. From the high Arctic to the hottest deserts, from the canopy of rainforests to the cracks in city sidewalks. They have survived mass extinctions, climate shifts, and the rise of mammals. Today, they are one of the dominant forces in the living world. We walk past them every day and rarely notice. Yet every trail of ants is a living demonstration of collective intelligence, emergent, flexible, and ancient. No single ant understands the colony's grand design. No ant holds a map of the nest or a plan for the harvest. The intelligence resides in the interactions, in the chemical conversations, in the simple rules repeated millions of times. In that sense, the ants hold up a quiet mirror. They show us that complexity does not always require a large brain. That cooperation can be more powerful than individual strength, that a society can thrive for tens of millions of years without kings, without written laws, and without rest. So the next time you see a thin, dark line moving across a path, pause. Kneel if you can. Watch for a moment. You are looking at one of the oldest and most sophisticated societies that has ever existed on this planet, an empire without emperors, a civilization written in scent and sacrifice, a quiet, relentless force that has outlasted continents and will almost certainly outlast us. The ants.